everybody. Today I am going to tell you about the zinc magnesium system. I have told you about the two component systems in which there is congruent melting point. So zinc magnesium system is a typical example of such systems which have congruent melting points. Congruent melting points means that the two components, the zinc and the magnesium, they will, when they are heated together, they will mix with each other and they will react with each other and they will form a solid compound by the name MgZn2. A solid compound MgZn2 is formed. So if we talk about the phase diagram of zinc magnesium system, it will have solid magnesium, solid zinc. These are the phases which are present. Solid MgZn2, liquid melt and vapor. Here we will ignore the vapor phase because we are keeping the pressure as constant. It is a solid liquid equilibrium and we will be ignoring the vapor phase. So all the phases, these phases will be present in this diagram. So now let's come over to the phase diagram of zinc magnesium system. So what we have here is pure zinc, 100% concentration of zinc, and here we are taking this axis, we are taking the 100% magnesium, and this is the temperature axis. This point A, this represents the freezing point, or you can say the melting point of pure zinc, that is 420 degrees centigrade. And here 650 degrees centigrade, this represents the melting point of pure magnesium. So when we take this magnesium and zinc system, we have this curve AB in this phase diagram. This AB represents, as we can see, we are having pure zinc over here and amounts of various proportions of magnesium are being added to it. So this is the pure melting point of pure zinc, and when we add magnesium to it, the freezing point will be changed like this, will be decreased in this manner till point B is reached. Freezing point जिंक का डिक्रीज होता जाता है जैसे जैसे हम लोग उसमें मैग्नीशियम ऐड करते जाते हैं, और कब तक डिक्रीज करता है, जब तक पॉइंट बी नहीं आ जाता। यहाँ पर क्या होता है, दोनों आपस में डिसॉल्व होकर के जो सॉलिड जिंक है वो सेपरेट होता जाता है, और जितना हम लोग मैग्नीशियम उसमें ऐड करते जाते हैं वो मेल्ट में डिसॉल्व होता जाता है। जिंक सेपरेट आउट होता जाता है और मैग्नीशियम उसमें डिसॉल्व आउट होता जाता है, और पॉइंट बी तक आकर क्या होता है, जो हमारे यहाँ पर जिंक सेपरेट आउट हो रहा था, अब जैसे कि हम लोग ने पहले टू कॉम्पोनेंट सिस्टम्स में यूटेक्टिक सिस्टम्स में पढ़ा था कि जो सॉलिड बी, जो कंपाउंड कंपोनेंट बी होता था वो भी सॉलिडिफाई होना शुरू हो जाता था, लेकिन यहाँ पर ऐसा नहीं होता है कंपोनेंट सिस्टम्स में। कंपोनेंट सिस्टम्स में कंपोनेंट ए और कंपोनेंट बी, जो यहाँ पर जिंक और मैग्नीशियम है, ये दोनों रिएक्ट करके एक नया कंपाउंड बनाएंगे जिसको कहते हैं MgZn2। पॉइंट बी के बाद क्या होगा, यही जो कंपाउंड सॉलिड कंपाउंड MgZn2 सेपरेट होना लग जाएगा। MgZn2 जो फॉर्म हुआ है बाय रिएक्शन ऑफ Mg and Zn, वो यहाँ पे सेपरेट होने लग जाएगा। यहाँ पे सेपरेट होगा, इस तरह से ये हमारा एक नया यूटेक्टिक पॉइंट बनेगा, और यहाँ पर 3 फेजेस इक्विलिब्रियम में होंगी। कौन कौन सी? जिंक सॉलिड होगी, सॉलिड MgZn2 जो कि अभिक्रिया के द्वारा बनाया गया है, और एक लिक्विड मेल्ट। इस तरह से हम पाएंगे कि यहाँ पर 3 फेजेस इक्विलिब्रियम में होंगी, और एक कंडेंस सिस्टम में जब 3 फेजेस इक्विलिब्रियम में हो और 2 कंपोनेंट सिस्टम हो तो naturally the degree of freedom will be 0. So this is our first eutectic point. So what does AB represent? AB represents the freezing curve of zinc to which varying proportions of Mg are being added, and B is the eutectic point. Now comes the curve BC. Now this BC, here MgZn2 has been formed. So BC will represent the freezing curve of MgZn2 to which varying proportions of Mg are continuously being added. And here what will happen? MgZn2 will again start separating out and the added magnesium will go into the melt. So this curve, this represents the equilibrium between the liquid melt and the solid MgZn2. So 2 phases are in equilibrium over here for component system. So the curve will be univariant. F dash will come out to be 1. So this is the curve BC. So the freezing point capitalize, this will be the maximum freezing point for MgZn2 system for MgZn2 solid to which Mg is being added. It reaches up to this point C, which corresponds to 590 degrees centigrades. And this, after this point, the freezing temperature will start decreasing again with the addition of with the addition of magnesium. So at this point C, what we have is solid magnesium MgZn2. This solid MgZn2 as well as we are having the liquid MgZn2 as well as the solid MgZn2. If we cool it below this 590 degrees centigrade, at this point means at this composition, which corresponds to 67% of zinc and 33% of magnesium, when we cool at this temperature, this is 590 degrees centigrade, when we cool it below 590 degrees centigrade, we will have a solid MgZn2. So what will happen at this point C? We will be having solid MgZn2, liquid MgZn2, means the composition of MgZn2 solid and MgZn2 liquid is same, but the phases are two. So we will be having two phases, but one component here over here. And if we calculate F dash over here, then it will come out to be at point C. If we calculate F dash, number of component will be 1. Why? Because the composition is same of the liquid and the solid. It is only MgZn2. So that will be 1. But the phases are two. One is the solid and another is the liquid. So it will be 1 minus 2 plus 1. And that comes out to be 0. So the degree of freedom will be 0. The system will be non-variant at this point C, which is also known as the congruent melting point of this MgZn system. The temperature corresponding to this is 590 degrees centigrade and the composition is fixed at 67% of zinc and 33% of the lead. So this is a typical feature of the congruent melting point systems. Both the temperature as well as the composition is fixed at this point and the system is non-variant at this point. Now let's come over to this curve CD. Now we are having the solid magnesium MgZn2 over here. So this represents the freezing point curve of MgZn2 to which more and more of magnesium is being added. So what will happen? The added magnesium will go to the melt and solid MgZn2 is again being separated out till point D is reached. Now at point D, we will be having solid MgZn2, solid Mg as well as the liquid melt. This means this is another eutectic point over here, as there are three phases in equilibrium. So F dash in a condensed system will again come out to be 0. This means that the system is non-variant at this point D. And it corresponds to 71% of magnesium and 29% of zinc and a temperature of 347 degrees centigrade. So we have seen that there are two eutectic points, one congruent melting point. We have seen this curve AB, BC, CD. Now come over to the last curve, which is ED. So what does ED represent? E is the melting point of pure magnesium. When we add zinc to it, the freezing point is lowered till point D is reached, which is the eutectic point I have just now. So this is all about the zinc magnesium system. The most salient feature of this is the formation of the compound MgZn2. Another feature is presence of two eutectic points, and one more feature is the presence of a congruent melting point, which is again just like a eutectic point, is non-variant and has a fixed composition and a fixed temperature also. If we observe this phase diagram, what we see is that it is actually a combination, a merging of two phase diagrams. One is diagram of zinc MgZn2 system. Okay, and this one is the another phase diagram CDE. This is actually the phase diagram of MgZn2 and the Mg system. Okay, so we can have two phase diagrams back to back over here, and so I think this is all about the zinc magnesium system. The two components, they form a solid compound MgZn2, which is stable up to its melting point. Thus, it is given the name congruent melting point systems. Thank you so much.